Hi, welcome to my video on graphing linear inequalities part 2, and this is the horizontal boundary line. The horizontal boundary line. Recall. There's a unit that we did previous on solving and graphing linear inequalities on a single variable. An example is that when you do linear inequalities on a single variable, then we have the set notation written out like this. This is a set of all x such that x is greater than or equal to 2, where x belongs to the integers. And in this case, it's a single variable, and in this case is in terms of x, so we have a single variable. So a single variable is on a number line, so 1, 2, 3, 4, etc. So it's greater than or equal to 2, so equal to 2 means that the 2 is included, and greater than is you shade to the, nope, my mistake, you can't shade. You have to use, allow me for a second to take that away with a little bit of whitener because I wasn't careful. Swatch, take it away, done. So what we have is greater than 2 and equal to 2, but they're only integers, dots that keep on going. We can also look at a single variable on the same inequality, but this time x belongs to the reals. And we have a number line, and it's a 0, 1, 2, 3, 4, 5, etc. And it starts at 2 because it's greater than or equal to 2, but it's belong to the reals, and the reals is the shading. So that's what I made a mistake up here. So notice these are only dots on the number lines, as integers are only dots. But when we do real numbers, we do shading. We shade in the number line equal to 2 and greater. So, and we can also do another one where we could have same idea, but we have the set of all x such that x is greater than 2, where x belongs to the real numbers. And again, 0, 1, 2, 3, 4, 5. So we have greater than 2, but not 2, so that 2 is hollow. And we shade in greater than is to the right. So we shade very similar to the previous one, but this is a solid dot is included. This is a hollow dot where it's not included. So that's what we did on one of the previous units. If you wish to find graphing and solving linear inequalities on a single variable. But in this unit, we're going to graph. The graphing is on the x, y plane, or we can call it xy axis. So that's xy axis is like this. So there's the axis, x, y, 0, 0 is the origin, etc., etc. So what's the difference in notation? Well, the difference in notation is that because we have the xy axis, we have the set of all x and y this time. And we have y is greater than or equal to, say, 2x plus 3. And again, we have an option, but x, most times when you do x and y axes, we graph on the reals. So, to illustrate that, we have the y-intercept of 3, and we go rise 2 to the right one, and this line, boundary line, is an equal sign. So the boundary line is solid, and y is greater than is above the line. But to illustrate this, I wanted to do in relation to a single variable, which is on a number line. And this is in relation to the double variable, or two variables. So you can see x, y, and we normally graph over the real numbers. But what you will not see or asked to do a lot of times, is that you will not, given the same inequality, you probably will not be asked to graph this over the integers. Because, just to give you an example, if that's the same line, if you graph, that's going through 3, pretend, but the integers are only dots, so the only thing you can do is you can't do a solid line. You have to do dots, and all the grid will be just dots like that, representing the integers on each of the ordered pairs where the lines intersect. And again, in this case, because it's equal to, I cannot have a solid line. I have to have dots. So just pretend we wipe out part of this and have just dots for the points. So I'll just take away some of it, much, and put some dots back in to represent points on a line, not dots are like this on this line. And no shading, just dots. Because integers, you can't have a half, or so you can't have, say, a point between 1 and 2. You can only have 1, 1, 2, 1, 2, 2, etc., 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 or 3, 0, or 4, 0, or 2, -1, or 3, -1, just dots. But the graphing we're going to do is pertaining to the set of real numbers. So we will have, just to explain again, so when we're graphing inequalities, so we're going to graph inequalities. When we graph inequalities, it's understood to be on the XY plane, and it's understood to be X and Y belong to the real numbers. R is for real. So that's just opening up in relation to the horizontal boundary line, just getting thinking. So let's do the horizontal boundary line. Graph on the XY plane. That means, again, we're graphing where X and Y belong to the real numbers. What about graphing Y equals 2 on this axis? So notice that Y is 2. So that means every ordered pair has a 2 for the Y. So that means X can be 0, X can be 1, X can be 2, X can be 3, Y is 2. So if you plot those points, X is 0, Y is 2, X is 1, Y is 2, X is 2, Y is 2, X is 3, Y is 2. What do you have? Well, actually, because we're only using the dots to represent the boundary line, equal sign is the boundary line. This boundary line is passing through all these points, and we shade them in, and what do we notice? What do we notice? We notice, excuse me, I got another pen here, this one ran out, that this is a horizontal line going through 2. So notice all the Y coordinates are 2, the X can be 0, a half, a 1, 1.5, 1.7, etc. So that's the boundary line Y equals 2. And it's equal sign, there's no shading above or below because it's only the points that lie on this line. Another way to look at this one is Y equals 2. So Y equals 0x plus 2, because a horizontal line has a slope of 0. So that's why you do not see an X. So if you plot the y-intercept of 2 and the slope is 0 over 1, that means you don't go up or down, you just go right 1, right 1. So you can see it's a horizontal line. So if this is the boundary line for, let's look at y is greater than or equal to 2, y is greater than 2, y is less than or equal to 2, y is less than 2. The boundary line is 2. And the boundary line here is, notice is equal sign, so the boundary line is solid. And above, greater than is above. So we go off. And this one, again, y is greater than 2. The boundary line is y equals 2. And the boundary line, this time, is no equal sign, so the boundary line is broken. So it's a horizontal line. Broken. And the shade above, greater is above. So again, take any point. Take this point, 0, 0. If you take 0, 0, y is 0. So if you put 0 here, 0 is greater than 2. No. So it's not the points down here that satisfy this inequality. It's the points up here. So take this point right here. So that point is 0, 3. So plug 3 in. 3 is greater than 2. Yes, so this point fits it. So it's the point above. And we have another inequality. So it's y equals 2 is the boundary line. So there's the 2. It's solid. So it's horizontal. And equal to is solid. And y is less than is below the line. So that means that all points below the line, all these points down here, this half plane, makes this true, and all the points on this line make this true. And again, we have y is less than 2, so we have a boundary line of y equals 2, so therefore we have, there's no equal sign, so we have a broken line, and that's 2 right there. That's 1, 2, 3, and y is less than is below. So you start at the line and go down. And again, all the points that's down here below this line fit this inequality, but the points on the line do not, because there's no equal sign. So, knowing that, if you see y all alone, you're graphing on the xy plane, you have a horizontal line. Because remember, if the boundary line for this one, the boundary line for all 4 of these, what is the boundary line? The boundary line is y equals -1. Because the equal sign is the boundary line in the equation. Okay, so now we have y is less than -1. So where's the -1? Well, the -1 is right here on the y-axis. It's a horizontal line. Notice that y equals 0x minus 1. The slope is 0 on this horizontal line. All y's coordinates are -1. But the boundary line is broken because there's no equal sign. And y is less than is below. And the boundary line is y equals -1, which is right there. But it's equal to, so it's a solid line. All points that's on this horizontal line make it equal, and all points above also. So it's the points on this, so the boundary line is y equals -1. Y equals -1 is the boundary line. And the boundary line here is y equals -1 again. But the boundary line is no equal sign, so it's broken. And y is greater than -1 is above. There it is. It's the half plane above this horizontal line. Y equals a number is a horizontal line through the -1. So we have, it's through -1. It's an equal sign, so it's a solid line. And y is less than is below. So all y coordinates of all these points down here, the y coordinates will be less than -1. And all the points also that's on this line because of the equal sign. y equals a number is a horizontal line, slope 0. I did that when we did the equation of a line. Check the unit on the equation of a line. Now, graph each on the xy axis. So now, what we have an inequality, but we have to solve. Notice this inequality only has one variable, y. So that means we have to solve for y. Y on the left, numbers on the right. 3 moves over to become negative. 4y is less than 4. We divide by 4. So y is less than 1. And so again, y is less than 1 is a horizontal line passing through 1. But the horizontal line is broken. Let's draw a broken line through 1. There it is. Horizontal through 1. That's 4. That's 1, 2, 3, 4. So there's the 1. And y is less than is below the line. So this is all the points shaded below this boundary line. And the boundary line is y equals 1. Is the boundary line. Number 2, let's solve this. This time we still have the y. And we move the y's to the left. We move the numbers to the right. Plus 5 becomes a minus 5. Minus 1 becomes plus 1, moving across the inequality sign. Negative 3y is greater than or equal to 6. We divide by negative 3. And we cancel, we get y. Because we're dividing by negative, that greater than becomes a less than, equal to, and that's negative 2. So notice when you divide an inequality by negative, it always changes direction. And notice we only have one variable in terms of y. So this is a horizontal boundary line at negative 2. And it's an equal sign, so it's solid. So there's the negative 2 right here. There's negative 4, negative 2. So we make it a horizontal line. And notice the horizontal line is parallel to the x-axis. And we shade y as less than. Less than is below the line. So there's all the points below the line and the points on the line that obeys this inequality. And number 3, we have fractions, and how I get rid of fractions. The LCD for 5, 3, and 15 is 15. So what I do, I multiply all parts. Now I can add on the opposite, like that, and I multiply by 15. Instead of subtracting, I add on the opposite. Now, that means when I multiply an equation with fractions by the LCD, every denominator should cancel. 5 into 15 goes 3. 3 times negative 2y is negative 6y. 3 into 15 goes 5. 5 times negative 2 is negative 10. Less than or equal to. 15 cancels, and I get a 4y, because that's a 1 times 4y. Negative 6y is negative 6y minus 4y, less than or equal to positive 10. So the y goes to the left to become a minus. The 10 goes to the right to become a plus. Add 10y less than or equal to 10. Divide by negative 10. Negative 10 cancels. And because I divided by negative, the less than changes to a greater than, equal to, and a minus 1. So I have a boundary line of y equals negative 1. Y is a negative 1 right here. And it's a horizontal line solid because it's an equal sign. So there it is, parallel to the x-axis. And y is greater is above this line. So all y coordinates of these points up here will be greater than negative 1. All points down here, the y coordinates will be less than. And number 4, we have to do a little bit of work on simplifying here. So we remove the brackets. Negative 12y plus 6 minus 2 greater than negative 15y minus 5. So 3 times negative 4, negative 12. 3 times 2 is 6. And negative 5 times 3y is negative 15y. Negative 5 times 1 is perfect. Now I simplify. I always make it a habit of simplifying first before I transpose. Why? Because you have less to transpose. We have one variable again. The variable will go to the left side. So negative 12y plus 15y greater than negative 5 minus 4. So the negative 15 becomes positive 15y, and the positive 4 becomes a minus. Add, I get a 3y is greater than negative 5, subtract 4 is a negative 9, divide by 3, and I get y. They cancel. Y is, now I divide it by 3, so it don't change. Dividing by 3 keeps the sign in the same direction. Greater than stays a greater than. And I get a negative 3. So I have a horizontal line again, y. The boundary line is y equals negative 3. And the boundary line is broken because there's no equal sign. So the boundary line is broken, passing through y equals 3. There's the boundary line. Y is greater than is above the line. So all points above this line will have all y coordinates greater than negative 3. So that brings us to the end of looking at graphing a horizontal inequality, horizontal boundary line. And the horizontal boundary line above is greater, below is less. Hope you enjoyed my video. If you did, click the like button, click the subscribe button, and notification bell because there's more videos coming. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's going to be on my YouTube channel, Math Fully Explained. Thank you for viewing my video. Bye-bye.